Hi there, boys and girls. I want to go through a quick derivative of sine and cosine. I'm going to do one proof with you. We're going to go look at a geometric interpretation, and then we're going to be done. So here we go. First of all, we're going to start with sine, and I'm going to do the limit definition to find the derivative of sine of x. So I'm going to set up my limit. This is going to be the limit as h drops to 0 of f of x plus h minus f of x all over h. And in trig, you learned the sine of a plus b expansion, so that is sine x cosine h plus cosine x sine h. So there's the expansion for sine of x plus h. And then we still have minus sine of x and then all over h. And again, this is going to find the derivative of sine of x. I'm going to rearrange some things in the numerator. So that's going to be the limit as h drops to 0 of negative sine x, I just brought this to the front, plus sine x cosine h. The reason I did that is I've got like terms so that I can factor something out. And then I still have plus cosine x sine h. And this is all over h. Okay, so what I'm going to do next is I'm going to factor out a negative sign from this first part. So that's going to be negative sine x times 1 minus cosine h. I'm going to leave the second part alone. And I'm going to separate these into two fractions with the same denominator. Okay, you learned two special trig limits last year, and one of those trig limits is the limit as h approaches 0 of 1 minus cosine h over h. This limit right here is 0. So we have negative sine x times 0. You also should have learned that sine h over h, that limit as h drops to 0 is 1. Plus cosine x times 1, and we get that the derivative of sine is, that's supposed to be a c, the derivative of sine is cosine. So that's the first thing you need to know. The derivative of sine is cosine. Now I want to go take a look at a geometric interpretation of this. Why did this work out to be that way? Let's go to our next page. What I have pulled off my TI-89 here, and the thin line is your graph of sine of x, and the bold line is the graph of cosine of x, and I want to talk about why that is the derivative. Let's first of all look at horizontal tangents for sine of x. Sine has horizontal tangents everywhere I'm putting the blue line here. That is a horizontal tangent. And I want you to take a look at where the derivative is at that same x value. So we come down here and we find the derivative. The derivative is on the x-axis. That is because the derivative is the slope. So if we have a horizontal tangent, then f prime better be 0. So f prime, which is cosine, equals 0 where f, which is sine, has horizontal tangents, which is something that we've been studying the last couple days. Very important thing for us coming very soon. We're going to want to know what this means when a graph has horizontal tangents, and this connection to the fact that its derivative is always 0 everywhere you've got horizontal tangents. Okay, hold on just 1 second here. Okay, so that's one geometric interpretation of y. Now here's something else I'd like you to look at. Everywhere sine is decreasing. Sine is decreasing from this horizontal tangent to this horizontal tangent. Where is the graph of its derivative? Between these 2 points, f prime is negative. So f prime, which is cosine x, is less than 0, where f equals sine x is decreasing. So there's another geometric argument of why cosine describes the slope. Where sine is decreasing, you're going to have negative slopes. Then take a look at what happens after that. When sine starts to increase and you have positive slopes, where is the graph of the derivative? The derivative is above the x-axis. So f prime, which is cosine, is positive, where our graph of sine is increasing. So this is why cosine is the derivative of sine. It describes the slopes. Everywhere sine has horizontal tangents, it has zeros. Everywhere sine is decreasing, it's below the x-axis. And everywhere sine is increasing, it's above the x-axis. Let's go write a few things out here. So we now know that the derivative of sine of x is cosine x. I'm going to let you graph and figure out why. The next thing is true. The derivative of cosine of x is negative sine of x. If you were to graph sine of x reflected over the x-axis, you would see that it is the derivative of cosine. So, if you happen to have to do the derivative of negative sine of x, I want you to think about that as like a negative 1 in front of that sine of x, and we can use our constant multiple rule, which means we can pull that out and do negative 1 times the derivative of sine of x, which would be negative 1 times cosine x, or negative cosine x. Same thing would be true if we did the derivative of negative cosine x. That would be negative 1 times the derivative of cosine, which would be negative times negative sine of x, which would work out to be positive sine of x. You got to keep all those straight. Okay, so you're going to practice some of these tomorrow, and that, by the way, that proof that we did at the beginning, right here, you guys are responsible for that. See you guys tomorrow.